Hi everyone, this is Dr. Siddhaling. I'm expert in machine learning and data science. In the previous video, I have given an explanation about how do we create the text summary using the pronoun replacement. This particular technique is published in IEEE. You can access this one through the link and for the previous video as well as the paper along with the GitHub. The code for this particular explanation is also given in the code. Let's go ahead and check it out, the code part of the this technique. The various modules which are used to build the complete code are numpy, regular expression, NLTK. So we will use the NLTK in order to identify the stop word, remove those stop word, and perform the position tagging, etc. We will do take a use of it. We will also use the counter, and that is the provided by the collections module, counter to count the total number of word and their frequency. So usually the first step I usually do is change the current working directory to the place where the complete code along with the input text is present. Let me also show the input text. So this is the type of the input text. It's basically the string explaining the cricket. So this is obtained from one of the websites. So you can see it's a plain text. So using this particular text, we will apply the text summarization, and we will also understand what is meant by pronoun replacement. All these detail we will take a look at during these explanation. So initially we will read the complete text part, and a user specify how much percentage of summary is required. Suppose there are 100 lines, user want to specify only 50 most important lines are required, that he can specify, and only 50 lines are extracted with the help of this particular program. So this is basically an extractive technique, and it will find the weightage for each one of the sentence based on the keywords. So it will use the keyword, identify the weightage for each one of the keyword, and then those weightage of the each keyword are utilized to identify, compute the weightage for the each sentence, and each sentence is given a priority, and then we will pick up the best highest scored sentence, and then we will create the summary. And you know that there are stop word, something like if we take a complete sentence, there are several stop words which are present. So they are essential, but they are not acting any meaningful, so they act like a connection between and framing the complete grammatical sentence. But because we are more focused on the keyword based frequency technique, we don't want the stop word to be present in the sentence. So therefore we will utilize the NLTK stop word list, and we will also update this list with the help of update, so we can have more word or the punctuation, whichever you want to keep it as a stop word. So all these detailed functions I will explain with the help of sentences, each one by one. So we will initially pick up the entire text part. So this entire text part, we will read it, the whole file, and then start processing on that particular text part. So we will open that file initially, and then we will read the whole. Suppose if I print this part only, so let me go ahead and print, so it will read the entire textual part. So you can see this is the textual part that is coming and visible over here. So this is read, the complete text part is read in the line in. And then we will also do the pre-processing. So this is the pre-processing. So the pre-processing is a simple function that is I have given over here. The idea of the pre-processing is that to construct a specific point as the sentence. So maybe we have a sentence with extra comma, punctuations, and different question mark. All these are replaced as a period. So once it is replaced with a period, now we have a single punctuation which will be indicating the end of the sentence. So that's what exactly done during the pre-processing step. So next step after pre-processing, we will remove out all the stop words. So this is a very simple sentence. So if I run up to here, and let me show what exactly happened after. So let me run this part of the code, and I'd want to display only the part without any stop word. So this will be creating the text. You can see this is more squeezed, but all the important words are present over here. So only important words are kept and all the stop words are removed. And we will also compute what is the length of this complete text, the total number of words which are present after removal of the stop word. So these are all the key important keywords. So that is computed as NT. So NT, now in this particular case, if I type NT, it will give 148 total number of words which are present over here. Now, I will use the counter in order to count for each one of the word. Okay, I want to count how many times it is occurring within this particular text, and based on that frequency, I want to compute the weightage. Weightage for any word is the number of time it is occurring divided by 148. So that's how we will count the weightage for that word. And once the counter is used, the basic idea is to split at the space, and each one of the period or comma semicolon is initially replaced with a space, and space is used to split the entire text, and the counter will identify these words and count total number of frequency. Let me run up to frequency, starting from the reading of the line, and then we can see what is the content of these frequency word. So frequency word basically a dictionary. Now you can see that it is a dictionary consisting of the word, because we have split up the text based on the space, and that's how we can treat that is as a single word. So for example, club is occurring one time, communicate is a one time, core is one, so on. So we have few words. It is two times, innings is three times, so many times. Okay, so the more the frequency of that particular word, that much higher weightage it will be given. So and then we will also compute the weightage for that word by dividing each word with the help of NT. Now this frequency also I will display. Now this is the weightage. So again, this is also a dictionary. Now it is all the frequencies are divided by total number of words, that is 148, and then we will get the frequency weightage value over here. And for a given sentence, the original line, it is kept as it is. We will tag the words, so we will get the tagged information after executing tag words from the given line. So this is a particular function that is present over here, and this is basically tokenizes the given entire text, and then applies the position purpose tag given by NLTK. So I can show how what are the information that is present in the tag. Now suppose if I run this one tag, you can see the tagged is nothing but the various detailed position, something like whether it is a noun, pronoun, verb. All these details are listed out with the help of tagging. Now, the get the noun position out of this, because we want to replace the pronoun with the closest noun. So therefore, we want to identify the occurrence of noun in the original text or original tagged this particular information. So the get this particular function uses the find it iter. Let me go and show that. Basically this uses the find iter of the regular expression, and identify the both the start and the end of that particular word which is mentioned in the find iter. So it will that particular keyword, the starting position of that particular keyword has been listed. Now once we get position, so let me real quick run this get position and show the outcome of the get position. Now NNP, if I type it over here, it will show the outcome of get position. So this is basically a dictionary. So cricket is occurring at first location, the start of the cricket is at 0, also, and 1207, that is another position in which the cricket is occurring in the original line. So test is occurring at 1017, 2020 is occurring at 923. So these are the different relative locations. Now we can also get remove the from the NNP this one if we have the week or the month names. We don't want them to be replaced, so we will remove those things with the help of another function just to remove that from the given dictionary. So it's a very simple function. You can see that appended and deleted all the uh, these entries which are mentioned in this list. So basically it is a list of month as well as week. After refining that NNP, we will also locate the relative positions of pronouns, and thereby we can again the get pronoun position is utilized, very similar to the previous get noun function, but here the pronoun and again the find iter is used. It will extract the position where the pronoun occurring, both the start and end of that particular word, and the start of that particular word is noted and written as a dictionary. Let me run that and check it out. What are the different position at which the pronouns are occurring? Now we can see these locations. Now you can see that these are the relative locations. So it is occurred at 550. So before that, there is only one cricket, that is the noun that is being present. So logically speaking, the cricket has to be replaced at 550, 558 also. If you take a look at it, cricket will be replaced. So thereby the frequency of the noun cricket will be increased in that case, and we will divide all the sentences which are present in the text with the help of slash n whenever there is a end of the line, and divide it and create all the lines separately. Now this is the list that is present over here. So this is a list that is consisting of all the lines, because each one line is picked up and then we create the summary from that, and then followed by that pronoun replacement with the near. So we will replace in the original this list of lines by the real closest pronoun. So as I explained, the logical way of doing is that it is occurring at 550. So we will go back and list check it out whether one of the noun which is less than 550 and closer to 550, so that is going to be replaced in the position of it. Okay, so that's what exactly taking place in the pronoun replacement. So this is also another function. So this is the pronoun replacement. If I execute completely this code, it will show the part of it. So let me execute the pronoun replacement. So you can see they it. So 550, the location there, it is going to be replaced. So it is going to show in which location that is occurred, and with the help of the checking the list of the noun and their corresponding location, it is going to be replaced with the closest noun. Now we can now print. This is only kept for the calculation purpose. The so total percentage that is mentioned by the user is 70. So top 70% of the lines are now extracted from the given list. Now, there are two ways to obtain. One is I can show the original line where without replacement is there, and the one with the replacement. Now, as I told that this particular replacement is only for the calculation purpose, but when we are creating the summary, it is going to refer to the original sentences only, and then it will extract the top priority sentences, and then it is going to create the summary from there. Now reduce obtain summary. So we will see this particular function. The basic idea is to look at the weight values of each sentence is calculated by taking reference to the frequency. Now these are the frequency of the word. This is frequency is calculated also divided by nt, showing the weightage for each one of the keyword. That values are taken reference over here. and the weightage for the sentence is computed, and then priority of that particular sentences are obtained based on this weightage for each one of the line. So that is also taking place with the help of obtain priority of a line. So this is another function. So it is going to sort out basically the number of lines based on the weightage value. So that's how the highest weightage will be kept at the first, and then so on. So that's how we will get the weightage of that. So in order to get the original summary, the very important to know that the original order how it is the line is occurring, that should also be kept, and that can be kept by assigning the priority information in the same order. Now I have split up these sentences. Each sentence will be given the priority value in the same order, and pick up the lowest highest priority value in this particular having a lowest ranking. So that's topest value will be present, and pick up that and create the summary. Now, this part of the taking the summary and appending into the list is taken place with the help of for loop over here. So these are the for loop responsible for creating the final summary. So the final summary is also created and written by the obtain. So let us run this obtain summary, so we can take a look at it how the summary, and these are the various calculations are taking place within the obtain summary part of it. So weightage of each line is created, and the relative position, this is the priority showing 0 is the highest priority, and the maximum priority will be the one with the highest. Say 22 is the line which is having the highest lowest priority, and the highest is 0. So highest weightage will be this particular value will be the highest weightage for that particular sentence. So this will be picked up as the first one, so on. Okay, and then the order has to be also be maintained. So this is already present in the order list. So this is how starting from this to the end of that, along the order it is going to be created. Summary is going to be created. So we will also run, there are two ways in which we can supply the list. One is with the help of the original, and with the help of uh, the replaced pronoun, the pronoun with the noun values that can also be computed over here. So I can display the text part. 70% of the original text sentences are extracted in a having the higher weightage value, and then the text is the summary is created. Now you can see and read the sentences. And cricket is a bat and ball game played between. So I think it is making sense over here, and it is because the order is also restored when it is creating the summary. You can refer to both the paper as well as the GitHub link, which are I have given below in the description. So please write to me if you have any query or the questions and any suggestion. You are most welcome and write to me. Thank you everyone for watching this video.